Hi, this is a poster of my project. Its name is Detecting Community and Roles in Social Networks. Um, the goal of this project is to detect the community and roles simultaneously in a social network. The motivation of this project is that we can use this way to find out important person and role in a specific community in a Facebook. Um, before the we start before I start the project, I tested two data sets. One is LesMIS, the other one is Power Grid. LesMIS has only 77 nodes, and the Power Grid has around 5,000 nodes. But why I only put the result of LesMIS dataset here in my poster? Because the node is quite small. The node number is quite small, so we can easily to view different distribution of the community or roles. Let's see. This is a row of 5,000 networks in the Power Grid network. So you can see that it's not visible, right? Next step is that based on what we have, I did a research question. So the first research question is how to define the relationship, because we have relationship between role and community and role. So how can we define this relationship? Second, that how can we find out the relationship between community and roles? Third is that based on the relationship, how can we detect them simultaneously? At the start of my project, I first detect community in the data set. Then I detect roles in my data set. Then, based on the result of these two, I create a very basic method to find their relationship. Okay, now let's deep into the method of detecting community and detecting roles. For detecting the community, I use DANMF. Its full name is Deep Autocoder-like Non-Negative Matrix Factorization. The structure of this method is similar like autocoder. So it has two components. One is encoder component, one is decoder component. And DNMF is to try to learn the hierarchical mapping between the original network and the final community allocation. This is object function of the DANF method. Based on this method, I need to input how many community I need in the output. Then this one can generate some data that can use to draw the view like this. Yes, in the end I input number 4 for detecting number of community. So in the end we have 4 communities. The image A shows the distribution of the community in LesMIS dataset. As we can see, different community is labeled in different colors. Yeah, and in order to find out the difference between different communities, I use 3 quantitative criteria. One is betweenness centrality, PageRank, and the other is closeness entirety. In this image, we can see that for betweenness entirety, okay, we can zoom in. The community 3 has highest figure. So we can say that maybe the purple node is in the center, and the community 0 has very low figure. So we can say that the red one is community 0. For PageRank, the PageRank, this concept comes from website area. That means to calculate number of quality of links from other websites. In our project, we can use PageRank to find out which community is much more important, because it can receive, because important community receive more connection. So in this figure, we can say that community 1 receive more more connection. So we can say maybe the purple one is a community 1. The gray node is community 1. The community 1. For closeness entirety, we can see the figure that they community 1, 2, 3. They almost similar except community 1. This is yeah. So that means community 0, 2, 3, they are very near. Only community 3 a little bit far. Then I introduce the method to detecting the row in the dataset. I use the Rolex algorithm to detect the row in Lemma's dataset. The core idea of this algorithm is that if we collect the data about graph in matrix, then we can use matrix decomposition method to find out the structure of the data. This is an objective function of Rolex. Then we can see the result of detecting. Okay, result of the detecting rows. In this algorithm, I input number 3. That means I need only 3 output. I need only 3 row in output. So we can see that only 3 row 0, row 1, row 2, and each row labeled in different colors. For betweenness entirety figure, we can see that row 1 is in the center, in the center because it has higher mark. So we can say that orange node could be row 1. For PageRank, we can see that the row 1 has more figures, more data. So yeah, we can say that maybe the gray node is row 1, or maybe the orange one. For the closed centrality, this one is to that we can find that row 0 and row 2, they are close together. Only the row 1 a little bit far. Then after that, I create a figure that shows the relationship between each community and a row, because as we already grouping community and clustering community and rows, so in each community they distribute different rows. In this figure, we can see that community 0, in community 0, row 1 plays important row in here, because the row 1 has occupied almost 65% in the whole community 0, but row 0 only 0. Row 0 play 60%. Row 0 is more important. And in community 1 and community 2 and community 3, we can, they are not similar. Their distribution, row distribution, is not similar with community 0. Actually, I also did heat map for the relationship between community and row, but in the poster, because the limited area, I didn't put inside. I write in my final report here. This is a heat map for Lemons dataset. This is a heat map for the Power Grid dataset, and its y-axis is community, and row x-axis is row community. Is a row. And because we use two objective function to detect community and the rows, so in the end I use this equation 3. Try to use this method, this object function, to detect community and the row simultaneously. Here actually is a matrix, a filter matrix of actually it's this one. Is a filter matrix of relationship between row and community. In this equation 3, in order to reduce the error, so this figure should be higher. Higher the figure, the better the result. And I can introduce the meaning of different node, different word. The V is represent the filter matrix, and G is the row membership matrix. And F actually is a Frobenius norm. And here in this object function, VP represents adjacency matrix, and U actually is a different mapping. So if mapping has 3 or 4, so we have 4, 3, 2, 1. And A represents the community membership matrix. My conclusion is that this is all what I did in my project. Actually, I also did analysis for, as we can see, for the power data set. Also, I written in the final report. After that's all what I did, and my further research is that I try to first is to detect to use this function, this object function, to test whether this is valid to detect community and row simultaneously. Then second, that whether, because the relationship, because the this is relationship, right? If this figure is high or low, whether it gives positive or negative for the result. I mean, in the real world, like whether this one can find important person or important role in a specific community in a Facebook. The third further research that try to find that whether I can use transfer learning to detect community and roles, because transfer learning actually is a new technology, and inside it it has multiple task method function. So for multitask, I think one task can detect a community detection, the other task can be used to role detection. So maybe this one, yeah, multitask can try to detect them simultaneously. And yeah, that's all what I did in my project. Thanks for listening.